Hello! In this video, I want to go over some notes with you on how to calculate a permutation. Okay, a permutation is an arrangement of n distinct objects in a specific order. Okay, so when you think of permutations, I want you to think of the fact that order matters. Okay, order matters. So it's going to be the number of ways R objects can be selected from N objects. So whenever we say something like this, N is going to be your total. R is how many we're selecting. Okay. For example, how many ways can a photographer arrange 3 people for a photo? Okay, well, if you think about the first position here, how many choices of people are there? Well, 3. So we pick one, have them sit down in a chair or whatever. Then how many people are left to select for the second position? Okay, yes, 2. If you select one, how many are left for the first position? That would be 1. And then you're going to multiply those together. And you would tell me there are 6 arrangements. 6 arrangements or 6 possibilities of how to organize the people for the photo shoot. Okay. All right. So let's suppose we do one where we take a group of people and we want to place all of them. Okay. So that's kind of like what we just did. We have like 3 people. We want to place them all. That's going to be rule number 1 for permutations. So the number of permutations of n total, n distinct objects taken all together is n factorial. And I think I've mentioned with you before how to handle a factorial, like this one above here. If I had put in here 3 factorial, that would have been the same as doing 3 times 2 times 1, which is 6 if you multiply that all together. Also note the factorial on the graphing calculator. We should be able to get that if we hit math, go over to prob. Okay, so math, sneak this in here to the side. Go over to where it says PRB for probability. And it should be, I believe, choice number 4. That's where you're going to find the factorial as far as using it on your TI-84 calculator. Okay, all right, let's try a second example here. It says a business has a choice of 5 locations to establish its business. It decides to rank each according to their own criteria. How many ways can they rank the 5 locations? Okay, so if we want to place all 5, 2, 3, 4, 5 of the businesses, okay, well, how many places or locations, choices do we have for the first place? So we would have 5. Pick one. There would be 4 remaining for the second choice. Then there'd be a third, a second, and a first, or using rule number 1, that's the same as saying 5 factorial, which should be 120 ways for us to place, or 5 locations for those businesses. Okay. Second example here, suppose they only wish to rank the top 3. And you might be wondering, why are they putting the word rank in these examples? Okay, ranking implies order. And remember up here at the top, I mentioned to you that order matters with a permutation. So when they say rank the top 3, they're giving you an implied order that must happen. Okay, so the second example here, ranking the top 3. So we're only placing 3. So we would have 5 locations to pick for the first slot. So we pick one, then there would be 4 left, then there would only be 3. So we're not going clear down to 1 in the choices, so therefore it's not a factorial. So in this example, we have 60 ways to choose location. Alrighty then, rule number 2, arrangement of n objects in a specific order using R objects at a time is given by, okay, this formula right here. And yes, you are very welcome to add that to your formula sheet. Just remember the n is always the total number of objects or items or whatever it is you're talking about in the problem. The R is going to be how many you are selecting. Okay, so number selected. And it matters because if you were to do this in reverse, you're not going to come up with the correct answer. Okay, so let's try this here. It says, how many different arrangements of 3 boxcars can be selected from 8 boxcars for a train? Okay, and my disclaimer on this is that order is important because each car is to be delivered to a different location, thus indicating an implied order. All right, so we have a total of 8 boxcars. We're selecting 3. So in setting up the permutation, we would say it's an 8p3. Okay, and to try out that formula, we would do 8 factorial divide by 8 minus 3 factorial, or 8 factorial over 5 factorial, which is sort of cool if you did this by hand for one time. It's like 8, 7, 6, 4, 3, 2, 1, multiplied together, divide by 5, 4, 3, 2, 1, multiplied together. So it's kind of neat that these just cancel. You're left with 8 times 7 times 6. And if you were to work that out, you get 336 ways to organize your train. Okay, the other thing, I'll let you in on a little secret. We can also get to NPR using your handy-dandy graphing calculator. Okay, if you get in there to math, and I should switch colors because I usually do when I give you a little secret like this. In fact, let me take this back out. We can do a math. Well, maybe we can. Math, prob, and maybe if you were looking closely a second ago, you noticed that choice number 2 is actually an NPR. So if we wanted to enter this example with the trains, we could do 8, do your math prob, pick NPR, so it'll come out NPR on your screen, a 3, and press enter. And it certainly should give us the answer 336. Okay, so that's good to note. Note to self, okay? And yes, I'm okay with you doing that as long as you show me your setup like so, and then you can put the answer beside it. That would be fine. Okay, next example. How many ways can a chairperson and assistant chairperson be selected for a project if 7 applicants are available? Okay, so we're assuming that this is order matters because a chairperson and assistant chairperson indicates an order. So we have 7 people. We want a permutation of size 2. Okay, so if you want to do math prob number 2 to calculate, you certainly can. If you do formula, 7 factorial over 7 minus 2 factorial, or 7 factorial over 5 factorial. So if I write this out, okay, all of those terms divided by 5, 4, 3, 2, 1. And remember, these are all multiply. So the 5s go away. You're left with 7 times 6, which is 42 ways to select the chairperson and assistant chairperson. And again, you're fine to do math prob on your calculator. All right, next example. How many ways can 4 books be arranged on a shelf if they can be selected from 9 books? Okay, so the order is going to matter as we place them on the shelf. So let's do a 9p4. So 9 factorial. Maybe you're getting a little quicker at this. 9 minus 4 factorial. So 9 factorial over 5 factorial. 8, 7, 6, 5, 4, 3, 2, 1. If you like doing them this way, 5, 4, 3, 2, 1. Cross reduce. So I have to multiply 9 times 8 times 7 times 6 is what I'm left with. 3,024 ways. And again, you can do math prob. So you would do 9 and then calculator NPR with a 4. And it should give you the same answer. All right, last example here, or last type of problem. And actually, this formula you're going to for sure want to put on your formula sheet. Rule number 3. It says the number of permutations of n objects in which K1, K2, and so forth are alike is given by this formula right here. Okay? And in some ways, not that it has anything to do with the state of Mississippi, I like to call this the Mississippi rule. And that's just because when I think of the state of Mississippi, I have all of these repeated letters in there. Okay? And that's exactly what this formula is taken into consideration. Okay? So let me show you using my example with none other than the word Mississippi. How many permutations can be made from the letters in the word Mississippi? All right, so first thing you do, count how many letters you have in your word. Okay, so for Mississippi, there are 11 letters. Okay, these K's that I've indicated here for the sample are just the repeated letters. Okay, so like we could start out with, and some books will show it this way. Like they'll say, all right, the first letter is M. How many M's do you have? Well, 1. Okay, the next letter is I. Okay, well, it just so happens I repeats 4 times. K, the next one, S is the next letter, and there are 4 S's in Mississippi. And lastly, the letter P, of which there are 2 of those in Mississippi. So in following our formula here, N is how many letters you have. So 11 factorial divided by, and just to be safe, I'm going to put a parenthesis here. So really it's safe to put a parenthesis around that bottom of your formula so you don't make a calculation mistake. So the K's are just factorial on the bottom, and I don't worry about the 1. 1 factorial is just 1, so that's fine and dandy. So we'll do a 4 factorial, 4 factorial, 2 factorial, and these are multiplied together on the bottom. Okay, so then it becomes a challenge with your calculator. I hope you'll take a second and try this to make sure you can type it in correctly. The answer you should get is 34,650 ways to organize the letters in Mississippi. Okay, all right, one last example. I couldn't go away without giving you the word statistics to try. So how many arrangements are there for the letters in the word statistics? All right, so we'll start here with N. N, if you count how many letters there are, I count 10. First letter repeated, let's go with S. There are 3 S's. T, next letter repeated, there are 3 of those. And then I, counting 2 of those, and that should be all. Okay, so again, let's fill the formula. N factorial, so 10 factorials on the top. The bottom, put a parenthesis, 3 factorial, 3 factorial, 2 factorial. And again, those are multiplied together. Okay, so if you go through, load that in your calculator, you get 50,400. Okay, now something I didn't mention was factorial. Actually, maybe I did. Did I? Yes, I did at the top. Math Prob 4. That's where you're going to find. So we can do Math Prob Choice 4. That's where your factorial button lives. Okay? My other comment would be, if you have small factorials like these 3's here, if you can do a little bit of this math in your head, I know that always scares everybody, but like 3 factorial, that's just 6. 3 factorial, just 6. 2 factorial is just 2. Maybe it's quicker to just multiply this in your head and get, what do you get there, 72 divided by, my pen didn't work too well there, 72. So then 10 factorial divided by 72, maybe that's just a smidge quicker than going through all the factorials. Okay, don't have to at all, just a comment on the side. Okay, so again, these notes were all about permutations, and I hope you have fun counting your arrangements. Have a great day. Bye.